Hello everyone and welcome to Australia Build Week Online 2020. Thank you very much for taking time out of your busy schedule to be here. Whether you're an attendee, speaker, partner or sponsor, without you the event couldn't happen. So thank you very much for being here. On behalf of Oliver Kinross, I'd like to personally welcome you to the event that is running from the 7th to the 11th of December, all online. I'd like to take the opportunity to thank all of our sponsors for supporting us and making the event what it is. Before I introduce our speakers, just a reminder that if you have any questions for the speakers, you can submit them in the box on the right hand of your screen. If we do run out of time for questions, we'll send any unanswered ones to the speakers to answer after their session. Now, I'd like to hand you over to the speakers who will get started straight away. Thank you very much. I hope you enjoy the event.
Okay, I think we're ready to go. Let me just move a couple of windows. Hi everyone, my name is Shales. Today I wanted to speak about EnviroBIM, and rather than talking about something incredibly technical, we'd rather focus on something that would aim at more conscious design decisions with our buildings. And at Nettletontribe, we've been pushing this all year, and we've seen the benefits it can bring. Our clients have loved everything that we've done so far, and it's gained a lot of trust. A little bit about myself. I've been in the industry for 20 years, and I have a Bachelor of Architecture and attempting to use it for good, not evil. Eventually, leading to my interests in digital design in architecture, and currently working as a BIM manager at Nettletontribe in Sydney, and currently implementing all kinds of workflows to create better outcomes for our work, focusing primarily on environmental analysis and BIM with computational and generative design, and we're getting into a bit of prefab work as well.
I'm sorry, Brad, to interrupt. Can you please turn on your webcam?
Oh, sorry. Can you see me?
Yeah, perfect. Thank you.
Okay. Can you still see my screen?
Yes, all good.
Okay, cool. Like many architects in Australia, we've joined the Architects Declare movement in Australia, very similar to Architecture 2030 commitments throughout the globe. And the Nettletontribe Sustainability Group have been working extremely hard all year, and especially with our digital design team, to use the tools that we've either purchased or created to create better outcomes for our work and understand carbon usage and how we can make better decisions for our projects. And recently, we're proud to say that Nettletontribe is officially carbon neutral as of December, which is amazing, and we're pushing that further. So watch that space. With many discussions with our sustainability engineers that we work with and collaborate with, we've tried to hone certain tests that we do on our projects, and that focused on 5 tests, which included energy intensity, daylight autonomy, renewable potential for projects as well, which has been a good one, and natural ventilation opportunities, outdoor comfort studies to also mitigate the heat island effect. And we generally approach these as we've required them for certain projects, so it's focused generally on the first 2, but we have developed workflows for the other ones as well. So I'll probably talk about tools that are more challenging to use and then through to the more user-friendly ones, but we have tried to implement all kinds of tools for the masses at Nettletontribe. Obviously, Ladybug Tools is probably our tool of choice as far as getting a very accurate test. And we've known Chris and Mustafa at Ladybug Tools for a while, and they're great to work with. They're heavily respected. The reason that we love these tools is because they're developed by some really amazing people, and they're incredibly customizable, so we can inject these analyses on any project at any time to focus on any area. They're incredibly collaborative, so we can share data amongst all kinds of vendors and push data all over the place. And the reliability of the results is very important to us, and we're getting very accurate results with the use of these tools. And with their tool set, it's basically covering all aspects of simulation for architectural projects, and whether it's daylight studies or shadow, radiation, heat ion effect, airflow, we can do almost anything we want with these tools, and we try to extend that as much as possible. And generally with projects, one of the first things that we do is analyze the weather and see where the wind is coming from and where the sun and the heat is actually coming from, which affects our projects. And we can do that on a yearly for the whole year, or we can focus more into the solstice and work out where we want to analyze for a specific project. And generally that leads to doing some sort of shadow analysis, which we can do very quick rasterized shadow analysis on large areas or small areas, and have a good understanding of the impact that this has. And then we can also focus more specifically and get quite accurate areas on how far shadow is impacting either our site or adjacent sites, and then doing something with that. And we can also adjust the way that we communicate these results. So we're in full control of how we communicate this. This was an example of just some daylight hours analysis on a potential site, and we could flick between each hour, which is easy to communicate with our clients. Daylight factor testing has been a common one, and especially on some of our commercial clients. And the scale might be an issue with some of these larger floor plates, but you can adjust the tests quite easily and get the results that you're after. In this instance, we were doing numerous studies on facade fenestration and how that impacts the light penetration into a floor plate. And also with this instance, we were looking at adjacent buildings and the materiality on an adjacent building and how the reflectance of some of those materials impacts the space of our proposed building. Also with larger floor plates, we can, when we're making large moves as far as cores and how that affects the architecture itself, we can see how that affects the daylight penetration, which obviously has an impact architecturally on facades and the way the space works, but then also the quality of the light within and how that is marketable. So we also do many student accommodation projects at Nettletontribe, and some of these spaces can be incredibly small and so we do numerous studies on the facade that sucks in the light to these small spaces, and it can see that some small moves within the facade articulation can have a huge impact of the space within. Oh, let's go back one. So in this instance, we did, I think it was 7 different studies These were predetermined and we were able to plug them in and get the results. But we also do this generatively as well, so we can have a design idea and go through the optioneering to create the best outcome for that. We also have to sometimes validate designs as far as their performance goes. So in this instance, these apartments needed to get 50% of the floor area to be 0.5 daylight factor in the space. So we worked with our sustainability engineers to devise this test and go through a few different options as far as the width of the facade that's impacting this space, and then how the facade, how close it is to the actual building facade, and what sort of impact that has. And we obviously had to get quite granular with the testing so that we knew that we were getting exactly 0.5 in the space and able to get the correct outcome. Radiation studies we also do. A lot of the times this is done in an early phase for the project just to understand where the positive and negative radiation is coming from and how that may impact our sun shading design on the project. This then leads to actual aperture and glazing areas design and how the sunshades design and what impact either it's horizontal or vertical shading and the extent of that, and you're trying to make the correct decision there. And also daylight hours, trying to get at least 2 hours in certain spaces on projects is important, especially with residential projects. And these are a common study that we do, and we're quickly able to articulate that to our clients. This was an example of a project in Caringbah, and we obviously had issues where the two larger pieces of the building were overshadowing each other, so we're able to tweak some angles to get that to work. So the issue with a lot of these things is we can do these tests quite easily, but trying to do more of these tests and at a larger scale is a challenge. And it's exciting to see Ladybug Tools that have rebuilt their tool set to make them available to the cloud, and Pollination Cloud is available soon. So they've also had a small session to a small group of people, like 4 studios, for the AEC Tech Forum, and it looked pretty amazing. Everyone that was involved with that was very excited, and I know that I'm excited to see the potential of this. It seems hugely scalable, and it'll be interesting to see how much this will equate to dollars and cents as far as Nettletontribe is concerned. So a lot of this discussion is basically talking about things that are outside of typical BIM authoring software, but these days with tools like Rhino inside, you're able to take data and geometry from numerous vendors and push the information around. So we've heavily been involved with Rhino inside and how that relates from on a Revit standpoint, and we've been using it on numerous tests. Our SEP65 test is a test that gets quite granular on specific rooms that require the test. So we ensure that the rooms get the correct amount of times it sees the sun at the right increments, and using Rhino inside, we're quickly able to extract the rooms and the walls and floors and roofs, get all the correct geometry out of Revit into Rhino, perform the test, and then we're able to push that back very quickly to a parameter in the room objects to see whether a specific room has passed or failed. So it's been incredibly helpful in that sense. Life cycle assessment of whole buildings or manufactured products or materials is something that we've been looking at more recently, and we just want to see how much embodied energy or how much carbon dioxide has been expelled to create certain materials, and we see that this is something very important. The good thing with something like this tool is that it's embedded into Revit and it works off something that we've already developed as far as our Revit families and assemblies and materials. So it's something we don't need to add too much to, and it works very well with BIM as far as creating different options, and you can visually see how much of an impact an option change will have on your project, which can be quite fast. And then you can create reports quite easily on the potential of your project as far as global warming goes, carbon output, and this can be exported as different material divisions or also Revit categories from your project. So a lot of the issue that we're having with some of these tools is just the learning curve that it is required to take on this. And it's not only just the basic software itself, but the tools and how they're used, and then also, even if you're just looking at daylight analysis studies, just understanding what light is and how it works. So there's a lot to take on, and the rabbit hole is very deep. So our aim is to basically create a tool that that people don't need to see the back end too much. They can just perform a test on a certain project and then get the result. So we're working forward to get some of these tools happening. But some of the things that we still do today is just produce imagery like this, which is straight from BIM authoring software. And it's a very compelling set of images, but it's probably at the wrong stage of the project and it's highly inaccurate. But we can obviously do better than this. Something like this also is just from an interior shot from BIM once again, just using Enscape as a rendering tool. But the accuracy is probably questionable, but this definitely is very compelling, and it does aim at another side of the brain, which is more of a look and feel of the space, which is also very important when you're trying to make decisions. We still use Insight quite a lot, which is within Autodesk ecosystem. We find it quite beneficial because if you're comparing different options within the same Revit model, you're basically comparing two options within the same model. So you can get a very easy comparative analysis done. Once again, the results are probably questionable, but if you're choosing option A and option B, then you'll be able to definitely see that. We do the same with daylight studies. That's another beta test that is available within Insight. Cove tool is another tool plugin that is a plugin into Revit and Rhino and numerous other vendors. It is an extremely powerful tool, and we're very interested in it, and it's something that we'll be picking up probably in the future. But the aim is to get something like this, which we have tried to make as user-friendly as possible, but it's still a challenge to navigate, and to get this not visible and just as a button within an app, which led us to tools like Giraffe, which you can create quick massing studies for a project. And then this is an example of someone else's tool, but this is just based off a Grasshopper script that you can easily run within your own network. So we're creating our own tests at Nettletontribe to do on simple mass forms, and that will be coming early next year. And it's always exciting to see how OpenBIM is developing, and it's just a shout out to Dion and the Blender crew as far as integrating Ladybug tools into an OpenBIM software, and it's incredibly exciting to see some of these things happening, which is great. So on that note, I'd like to say thank you for attending. It's been a pleasure to discuss some of my thoughts today, and thank you very much.
Thank you very much for your presentation, Brad. Now I would like to introduce our sponsor for today's session, Bricsys. Please welcome Omar, Regional Director for Australia and New Zealand at Bricsys, and Sagar, Technical Lead APAC at Bricsys, for their presentation. Now over to you, Omar.
Thank you very much for that. Just give me one moment and I will share my screen. There we go. Hopefully everyone can see this okay. Look, thank you very much for joining us. My name's Omar Awny. I'm the Regional Director for Bricsys Australia and New Zealand. And I'm joined today by my colleague Sagar Thorat, who will be demonstrating some of the technologies that we'll be discussing shortly. Hopefully by the end of this session, you'll have gained some further insight into how artificial intelligence and machine learning in particular can help you and the whole industry deliver better projects. So let's start with a few definitions, because I think just like BIM, if you were asked to ask a group of people if they understand what AI and machine learning are, most will say, you know, they do understand it, but the reality is not too many genuinely do. So if we start with intelligence, so intelligence has been defined in a lot of ways over the years, and you know, it's the capacity for logic, understanding, self-awareness, ability to learn, you know, reason, plan, being creative, critical thinking, and so on. AI is described as the ability to perceive, intelligence is also described as the ability to perceive or infer information that doesn't currently exist, right? So, you know, it can be applied towards adaptive behavior in an environment or in a particular environment or context. Think of it as, you know, general mental capability, right? And it's also involves learning quickly, learning from experience. But it's not, we're not talking about, you know, book learning. We're not talking about a specific academic skill or something like that, but rather a broader capability in, you know, that helps us comprehend our surroundings, making sense of it all, even if we don't necessarily know how it works or how it came to be. So, you know, historically, it's been associated, intelligence has been associated with humans and animals, of course. But since the late 50s and early 60s, that's the 1950s and 60s, of course, when computers were actually first able to beat world champion chess players at their own game, the term artificial intelligence has been discussed. I mean, back then, a computer that could beat a chess champion was considered quite intelligent. Today, of course, I mean, even your mobile phone can do that. And because of that, or I guess that highlights the fact that AI is in fact a moving target, right? The definition of it. Think of it as an esoteric utopia, if you will. The actual definition changes as we develop new technologies and discoveries, and you know, what's new becomes old, and we're looking for the next step. Machine learning, on the other hand, is more technical, right? It's more empirical. It's a subset of artificial intelligence, and it's seeing more and more use in everyday interactions. Think of, you know, Google and Alexa, and you know how they understand what we ask and provide answers. That's using machine learning. Speech controls in cars, and of course the various levels of autonomous vehicles themselves. So don't confuse this, by the way, with, you know, the branding tag of smart devices, because it's a little bit like the old internet-ready computers or multimedia capable PCs, right? even last week, I went to buy an electric toothbrush, and I saw on the box one of them said smart toothbrush. And when I asked, the guy, what's this all about? He said, it lets you know when you've brushed in one area enough and you can move on. How does it do that? Well, it beeps every couple of minutes. So, try to sort of look through the marketing hype and see what, machine learning and smart things and smart devices really are. So machine learning, it's about algorithms that build a model, initially based on, sorry, I just realized the slides aren't advancing. That's okay. There we go, bit of catch up. Okay, so machine learning, it's about algorithms that build a model based initially on some sample data known as training data. And it allows the machine to make predictions or decisions without being explicitly programmed to do so, right? So as I mentioned earlier, things like, speech, email filtering, computer vision, autonomous vehicle, and so on, they're all using machine learning. And its application across business problems is also growing. So how does it work? Just very quickly, there's several components. Obviously, the learning side of it, right? So we need to, initially, we need to define the desired outcomes. We need to teach the machine what it needs to do. We need usually some seed data, right? And then work out the curriculum of what to teach the machine and in order for it to achieve the outcomes you want. So in terms of machine learning, we have a number of learning techniques, if you will. So, the most basic one is supervised learning, where I teach the machine, for example, how to recognize the difference between, I don't know, a cat and a dog, a pedestrian and another car, or something like that. And then we also have unsupervised learning. And this is where the computer's given some example inputs and it tries to determine what's actually, what's happening with this PowerPoint, sorry, where the machine actually goes and finds its own structure and looking at the input that it's given. It can be a goal in itself, so discovering hidden patterns in data that we perhaps didn't see. And it can also be a means to an end, right? So things like feature learning. There's also reinforcement learning. And I quite like this one because it's a little bit like my kids. You kind of give them rewards and so on, but it's generally done with tokens and things like that. So we tell the machine to go and try and find or try and gain as many tokens as it can, which are the incentives. And the machine goes and figures out what it needs. It can even change what it needs to learn. So it's changing its own curriculum to suit whatever it needs to do. There's a few other things that are involved, of course. So we have things like, optimization. So it's not all just about learning. In terms of optimization, it's trying to figure out how many times it got things wrong or right and how it can improve that ratio. There's anomaly detection where, it can prioritize, again, what it needs to learn to be better at what it does. And then we get into the really high end of town, which is things like neural networks and so on, where you break the actual learning parts down into several modules and they all share what they've learned with each other so that the whole system gets better at doing what it does. Obviously, there's a lot more. There's things like federated learning and so on. But how does this all affect you? Well, imagine if machine learning, took away all your mundane, error-prone, repetitive tasks that you do, and allows you to focus on the high-value things, decisions and aesthetics, function, and so on. This is what computers have promised us all along from long ago, and now they're finally able to start delivering. The other thing they can give you is far greater insights into what's going wrong, or better yet, what may go wrong soon, right? It can pick up patterns that you haven't noticed yet, and it can help you take preemptive actions so that if something does go wrong, you can either avoid it or you can mitigate, the damage. that's caused. It's going to make, I think, machine learning will make things like progression of drawing boards to CAD and BIM look like baby steps in comparison. But of course, they were or are necessary evolutionary steps. So with that quick intro, I'll hand over to Sagar, who will just show you firsthand some areas where BRICSCAD is currently using machine learning to help our customers. Over to you, Sagar. Thank you.
Thank you, Omar, for the wonderful insights. I'm just going to share my screen now and hope that my first slide, there you go. So we will begin. All right, share my webcam. Okay. Hello, everyone. I hope yeah, my webcam is visible. All right. So we will begin our BRICSCAD's machine learning journey with quick build and how yeah. All right. So with the building mass we created, we can now show a first example of automation. So we will look at this building mass volume, and what we will do is that we shall use the quick build tool to automatically detect walls, floors, and slabs. So the machine learning algorithm here has run an volumetric analysis on this particular model, and it will be detecting building elements smartly. After this, what we shall do is we will be classifying these building elements. We will be isolating them and checking that if our algorithm worked perfectly. And this also allows us to further add building properties such as gross volumes. So what we would do, we can now move on to adding some custom properties, which will now combine the power of machine learning with your human intelligence, and you can keep adding more and more of these, and you're able to get assistance from the machine learning capabilities of BRICSCAD. In this case, we're adding a formula which will divide the gross volume by the total gross area, and hence we will get a value for the particular volume. And here you can see that my compactness ratio is about 4.38. And this is again a very quick way of building things, and initial tender design phase, you're able to present this to your clients in a much better way. So from mass model to concept design, what we are able to now achieve is not only a transformation of the mass model to a concept design model, but this can be used to evaluate design options, not only geometrically, but also quantities and compactness ratios such as floor to site ratios can be achieved. Now let's move on to the first AI innovation by BRICSCAD, which is known as BIMify. So post quick build, we will move on to BIMify. BIMify was launched about a few years ago. And what BIMify will do is that it will instantly convert your traditional models into a classified building information model. And before moving on, what I would like to do is introduce our industry partners such as HOK and Leica. Last year at the Bricsys conference, we announced a multi-year initiative that will advance the scan to BIM technology with Leica and HOK. And now we will introduce the convention center, the Kentucky Convention Center model for our next parts of the demonstrations. And I would invite Mr. Greg Schnausner, Design Technology Director at HOK, and hear from him how we are partnering together with HOK. Olga, hope the video is being played.
When we started working with Bricsys, we chose an existing project to reverse engineer, i.e., take a project we've already built, designed in other platforms, and rebuild that and use that basis of our work. So last year you saw the model reconstructed. This year you're going to see it used in demos. One of the main areas we focused on was drawing automation, And specifically, we started with something like fire life safety, which is a lot of effort. So you can see here, these kind of drawings are really laborious to produce. And so that was the basis of the collaboration. We think this way of working is a perfect process to go back and forth, to use the work that we've already done and help engage and add to the development of Bricsys.
All right, so that was our partnership with HOK, and we continue to deliver on the promise of OpenBIM and developing the BRICSCAD platform. So I would just like to confirm if my screen, yeah, fine, my screen is shared. So we will now begin importing a model taken from a traditional BIM platform such as Revit, and we shall import it using filters. So your Revit project import allows you to import building information models, and you are able to filter them, such as, for example, if you would like to only look at rooms or walls and spaces, you could only import those components in the model. And when the model is imported inside BRICSCAD, you can see here that these are identified as 3D solids and block references. We could use the power of BIMify to auto-detect building components inside BRICSCAD, and the auto detection inside BRICSCAD will help to attach metadata to this model. And further to that, you can now start working on this model, such as, for example, you could start working on a building interior layout. And with this power of converting any 3D solid model to a building information model, BRICSCAD is offering a complete open BIM platform to the entire industry, which we hope to improve further with more machine learning tools such as BIMify. In this case, I'm able to quickly do some permutations and combinations in the interior design of the project, and I can take it further to a level of detail that will keep increasing as we progress in the process. All right, so now let's look at the star of machine learning in BRICSCAD, and the tool is Propagate. So Propagate is basically propagation of an idea of a detail into your architectural or structural models. So now let's look at these walls, basically, which are an enclosure to the ducts. And we have now created a particular type of a plaster board which has the fire properties embedded inside it. And we will first attach that type of a wall to these duct walls. We will move into our details panel. These are parametric details which have been predefined as part of our design process. And now a simple drag and drop will take help of the machine learning inside BRICSCAD and identify the locations where this particular skirting board of 60 mm is applicable. And BRICSCAD identifies that there are around 48 locations where this can be applied, and we can immediately accept or go zoom into these particular locations and allow it to accept these, and the modification in the model will be visible in all the locations. So now you can see that this skirting, in a flash of a second, was attached to all of these walls in the entire 128 locations. So this is the power of machine learning that BRICSCAD offers during your building information modeling process. Further to that, we are also collaborating with industry partners like IFC and BCF to open up the BIM world. And with the help of the BIM RV SDK, we are now able to import different sorts of models as well. Now, for this demonstration, we will look at the truss, which is part of the Kentucky Convention Center. And this truss is missing certain critical information, such as details at critical junctions at the bottom part of the bottom girder of the truss. Here we can see that we have a BCF panel, which is integrated inside BRICSCAD. In the BCF panel, we see there are about 17 issues, and we have identified this particular issue, which is the most critical issue, and it has been identified in particular locations. So here you see that there is an unresolved detail between the main beam and the sub beam. There are certain predefined details that we are proposing and propagating now with the use of machine learning, propagating this detail in the entire model, and machine learning will basically search, run the algorithm, and find that there are about 48 suggestions. So here you go. This is where machine learning will assist you in your building information modeling process and design process. Now we have immediately applied 48 details in all of these locations, and this can further be documented using the BCF format, and this can then be sent as an IFC model to a structural engineer or somebody who is using a fabrication software to fabricate these particular plates or beams and check the integrity of these structures. Now let's look at the export of IFC. So here I would like to point out that BRICSCAD is IFC certified, and we are an international member of Building Smart. We are able to export this entire truss as an IFC model, and by doing so, we can export it as IFC 2x3 or IFC 4. You can open it in an IFC viewer or in any software that accepts IFC as its collaboration platform. Here we are opening the Bricsys 247, and using the Bricsys 247, we are now able to open this IFC file, have a look at this truss, and find the components inside this truss and check the integrity of the metadata. And this is the power of OpenBIM, where you're able to, at the same time, get a model from a third party or any other traditional BIM platforms, bring it into BRICSCAD, use the power of BIMify, propagate, create details, and then share it using the IFC platform. In the interest of time, I'm just going to move a bit faster. Now, let's look at how we have integrated machine learning in one of the most tedious tasks of this decade, which is scan to BIM. So scan to BIM applications have been picking up in the industry. And what BRICSCAD has done is it has used its multi-threading capability in coding to complement the multi-threading capacities of your chipsets that your processor uses. And by this, you are able to import almost 100 GB point clouds very fast. And we are able to bring in E57 files. We are able to crop these point clouds. And let's say now I'm going to particularly define an area. I can get into this bubble, which is your scan location. You can actually go inside the scan location, identify the objects. You can review the scan, and later, further to this, now I would like to use the auto detection tools, the machine learning tools inside BRICSCAD to create a volume section. And by creating a volume section, we are actually identifying flow plates. And these flow plates will have further, we can use these flow plates to create your 2D plans. Now, the 2D plans is basically a connected line work. We will automatically detect walls, and we will open this 2D drawing as a new drawing. It's also possible to open it in your same drawing. So now you see that the AI assist or the machine learning is actually scanning through the point cloud at a particular level and automatically creating 2D line work with a background raster image. This 2D line work now can be optimized, and further you can use it for your scan to BIM. So that's about 2D AI, and now let's move into 3D auto detection of surfaces. We can now move inside this particular scan view, and we will use the fit planar command. Fit planar is another AI assist tool which basically scans through point clouds and identifies rectangular surfaces of walls. In this case, you can look at the left window how we are automatically detecting using this joystick. So it's more like a gaming interface. You use this joystick to determine your surfaces, determine your floors, determine your walls, and move faster in the scan to BIM process. This wasn't possible 2 years ago or 3 years ago, maybe with third-party application tools, but now with the power of BRICSCAD and machine learning, it's possible. And this is where BRICSCAD has, or Bricsys has, more data scientists and PhD holders in their development team and their technical team than perhaps we have other salespeople, for example. So in this case, we are now using the fit planar even externally. And now by hiding the point cloud, I'm able to see what I was able to generate within 30 seconds. I was able to create a room, and this is accurate to the point cloud data. So the better your scan, so let's say, for example, if you use the world-class Leica scanners to do your scanning at an accuracy of 1 millimeter or 0.5 millimeters, then your scan to BIM models are going to be even better. Further, you can actually combine this scanned point clouds with actual BIM data and create amazing documentation using BRICSCAD BIM's tagging techniques or documentation techniques or annotation techniques. All right, for the last part of the session, now we would like to move into the collaboration between Leica and Bricsys, both being part of the Hexagon family, and we are working very hard to improve your scan to BIM workflows, not only the standard survey workflows, but also the high definition scanners such as the Leica scanners, which can be used, mobile scanners which can be used, or the RT360, which also can be used as on your tripods. Now let's look at end-to-end field to BIM and BIM to field workflow using Leica scanners and BRICSCAD. Now, this is a full end-to-end workflow to digitize reality. So using the Leica scanner, we are going to capture this particular auditorium, and we will then further export this as an LGS file or a point cloud file and take it into BRICSCAD. So let's get started. First, we will be at the site using the Leica MS60 and Leica RTC360, and with target points set inside this auditorium, our team of technical specialists will be acquiring this scan data and combine it with the survey data. So using your mobile device, you're able to run your pre-processing of your scan, and once your scans are in there, you can actually now start adding these IDs using your MS360, which is your accurate geospatial locations of those particular points that you have placed them to be identified. And let's now move on. We will now export this model into BRICSCAD, and BRICSCAD has a direct plugin of CloudWorks sitting inside BRICSCAD, which can further be combined with the power of BRICSCAD's direct 3D modeling and building information modeling, and CloudWorks auto detection tools can be used as well together with BRICSCAD, and this speeds up your scan to BIM workflows literally 5x, and this is the best in class technology that you can make use of for your scan to BIM projects. Here we are now created the building information model. We are going to upload it to Bricsys 24/7's common data environment for transferring this data to Leica Icon, and Leica Icon can be used on site for detection of these points and for positioning of these points further. All right, so that was in short the AI, the BIM, the machine learning, and how BRICSCAD is moving forward in changing the game in the industry today. So partner with us, let us know how we can improve your workflow. So with this, I would like to end this session, and I would ask Olga to please take over.
Hello, everybody. Sagar, would you like to on the introductions?
Sure. So because I didn't hear the first part of Olga, probably there was some. All right. So welcome everyone to this panel discussion on AI and machine learning in the AEC industry today. We have a stage of panelists here, industry experts, and I would like to introduce Ben Harlan. Ben Harlan is the digital design and delivery practice lead for Mott MacDonald. Our second guest here, Holger de Groot, CEO and founder of Pensate Australia. He's also on the board of directors at BSA and a sessional lecturer at UNSW. And of course, we have the Bricsys team, Omar, regional director for Australia and New Zealand Bricsys, and Damian Harkin, the owner and director of Sofoco. So it's a pleasure to be moderating or to be assisting on this. So let's get started. So my first question to start the discussion here today would be, how widely do you see AI and machine learning, or rather just say machine learning, currently being applied across AEC industry today? Hope the question was clear. Okay.
Yeah, that's clear. Thanks. I'm happy to jump in first. I'll say in general, it's pretty weak AI. Often what you might call advanced automation rather than intelligence. There are some good examples. I've seen a very nice one inside my company where we've developed accurate prediction of contaminant distribution across Auckland's beaches based on a city model, weather forecasts, condition monitoring of pipe networks and historic data. But I think generally we're still at a very weak level where we might use AI for something like denoising images or looking for problems in asset data.
Yeah, I think I can agree with that. Well, on my field, like we have seen AI and less machine learning, but a bit of AI being used during the design process. For example, using data-driven design to make more informed design decisions. But it's really at the beginning. Most companies haven't really touched it yet, partially because they don't have the resources or don't have access to such technology. So answering your question, I personally believe that we just started. Many other emerging topics within this field are only beginning to gain traction.
Yeah, look, I think perhaps
I have to say that there's been little use of these tools so far amongst our clients, but I'm excited about things like just Propagate. It allows, well, typically something would be drawn in 2D as a typical detail, and the builder has to apply this detail all through the job. But now we're able to actually model that complex detail and propagate it through the model. And it means when you get quantities out of the model, like the length of skirting board, for example, in your example, you know, the information is there. And it would be impossible or just too difficult to model it all manually. So yeah, that becomes very significant.
I think also to Ben and Holger's points, perhaps machine learning in our industry is a little bit behind compared to others, predominantly because to get going, you really need some data to start learning with. So Ben, in your example, you know, you had a city model, you had a lot of information about how things, how chemical spills propagate. But I think, you know, at this stage, we're a little bit like the old days with blocks where people didn't want to share their AutoCAD blocks. People don't want to share the data about their projects. But if you think in another, you know, I'm not going to predict how long, let's just say it's 5 years, and people are happy to share information just like we do with Google about driving and so on, where in return you will get a lot of insights into projects in your area or in your, you know, field of specialization using all that data.
All right, so those were, I mean, we moved from understanding AI in terms of how you depixelate, or that's something like which is very flat 2D in terms of images, to pipe networks, to using propagate. So it's really mixed. It's there, but it's in bits and pieces. That is what we take away from this particular question. So now let's move on to the next question, and let's say I'll move on to the third one. The third one is, what benefit would the industry gain by implementing AI machine learning in the construction process?
Should I jump in? Well, I expect that AI and machine learning in the construction industry will definitely increase efficiency throughout the entire value chain. So starting from production of building materials to the design and documentation process, and then of course in the construction process as well, using all the data that has been summarized and developed over these spaces. As I mentioned before, we started in design during the design and planning process. But AI and ML could also simplify the process of clash detection and coordination during construction. So using, for example, existing building information models, using data that has been gathered on site, for example, by drones, cameras, and then automatically comparing the as-built and the virtual model, the building information model, to see where things do not line up, and then come up with solutions, or actually changing the documentation or the designs so it actually fits again, and it can be fixed in a short period of time.
I think it also allows us to do more, to tackle more complex questions. The more we get humans thinking a little bit like, we get computers thinking a little bit like a human mind, we're able to use things like fuzzy logic or neural networks to tackle very complicated things, which at the moment is just too difficult or too time consuming to write very, very complex traditional programming to solve. But if we're happy with an approximate answer from something like a neural network, yeah, we're able to do more and more complex analysis too.
I think we're just at the beginning. At the moment, to BIMify a model, the BIMify AI has been trained on a lot of well-defined BIM models where everything's been classified already. And so it learns that this is a column and that's a beam. And we can then BIMify a dumb model and recognize the columns and beams. I think that can go a lot further. If we've got properly labeled spaces and BRICSCAD can handle spaces and floors, we could BIMify a model and recognize the kitchen and the lounge room and the bedrooms. And from that, you could start to build a requirement list for a 3-bedroom house or for a 200-bedroom casino. Or, you know, you could make up rules and get BRICSCAD to create such a thing just by knowledge of the ones it's been trained on. And you could say, I want a 3-bedroom house in the style of Harry Seidler or Le Corbusier, you know, and the software could propose something which matches the things that it's been trained on. And maybe that's just dreaming, but you know, the rooms and the spaces required and the connections between those spaces are all capable of being recognised and then applied on another job. So I think the team at Bricsys is just going to keep going and finding new things to do with it.
Yeah, I would agree, and I think looking further into the future, I imagine, you know, let's say you're the project manager for a particular job, and you know, imagine having an app on your phone that is collecting data and analyzing it, and obviously using machine learning in the background and saying, hey, you know, there's actually a lot of buildings, a lot of construction work going on in Sydney. Looking at the amount of concrete in these jobs, there's going to be a bit of a shortage, so you know, plan ahead. Or you know, we typically get a lot of rain around a particular month, so you may expect, you know, this many days of stoppages because of weather. All those sorts of things. I mean, you know, the sky's the limit, you know, and it really is about just getting enough information from so many different sources and learning what to look for in those patterns.
I think we have gathered really interesting insights on this, and especially if I start with Holger's speech in terms of understanding of data which is as built, and then using understanding the logics of buildability, and then relating that to clash detection, and gathering as much as data as possible is probably the most important thing. And again, the geospatial locations could also play a role over here in terms of how each object, like a column or a beam, relate to each other. And of course, again, there are patterns which need to be understood, which we do understand from Ben as well, that patterns such as neural networks, these are certain things which will also impact. So there's a lot of information which needs to be compartmentalized, and we would have to learn in the process. Like Damian said, we're just getting started. So there's a lot of insight that we can gain from your talks today. So thanks for that. Now I'll move on to the last question, which would be, okay, so what are the roadblocks that you see to implement AI and machine learning in construction process management?
I have strong views on this, so I'm happy to jump in first. I think there's, in the AEC industry, there's a bit of hesitation to absorb non-traditional roles into our teams. So having data science embedded in teams of engineers. So I think that cultural resistance to partnering and having cross-sector skills with non-traditional engineering roles is very, very important. And the teams that are able to merge those the fastest will leave others behind, in my view. That's particularly an issue for big organizations that have dominated areas of the AEC industry for a long time, and I'm in one of those. We see it as a very real risk that we may become complacent and traditionally minded.
I believe it's not just the hesitation itself as well, it's also the fragmentation of our industry with many small companies and only a few large ones. And that has created silos over recent years or decades that are only accessible by some of us or selected groups. And that also means that the financial resources we have for development and research within those companies or within our industry to make significant changes or bringing in something new that could actually improve not just the workflows for me as the company, but also for the industry itself. That is more difficult compared to other industry that are more concentrated, such as the automobile industry, for example.
Damian?
Omar, Damian.
Oh, sorry. Yeah, look, I think to add to that, perhaps, you know, I'm going to go back to data. I think there's a lot of companies that aren't collecting enough data to make meaningful decisions from that. And if they do, I know a few that do, they're not willing to share that information. And it's only when you start to share that data in exchange for greater insights that we'll get further progress. I think the fragmented marketplace that Holger mentioned is also another one. I think also there's a little bit of, let's call it trust issues, where people are yet to fully trust that a computer can make certain decisions or at least suggestions perhaps better than we can or quicker than we can and still be super accurate. You know, that comes in automotive where people, you know, wouldn't trust a fully autonomous vehicle just yet, a lot of people. So it's being introduced bit by bit.
I think you're right about collecting the data. The Tesla cars all have 8 cameras and they're all collecting information all the time and learning as they go. And I don't know how you do that in the building industry. That's it's very difficult.
And all that data that they're collecting, I mean, it's going back to Tesla. So, I mean, if there's a pothole in the road, they're going to know before most others, right?
Yeah, but even if it doesn't know the potholes there, it knows all about potholes in general, and it's it'll recognise it on the fly.
So just one thing that, sorry, Omar, please go on.
Go ahead.
Okay, so would it help if city authorities or we as industry professionals set up an advisory board which actually enables for the open source creation of city mapping data, which is anyways getting created? People are creating smart cities using different IoT devices. They are getting implemented in pockets everywhere, but the city data, is it available, like the digitized reality data, is it available for everybody to access? Would open source city mapping data help to expedite the implementation?
I think it would help, but it's not the be all and end all, I guess. I'm just noting the time, and the organisers are asking us to wrap up a little bit. Well, to wrap up. So, guys, I wanted to thank you on behalf of Bricsys for joining us here. Your input is very valuable. Sagar, thank you for the demonstrations and for moderating the panel discussion. If anyone has any questions in the audience, please type them in and we can answer you textually or get back to you another way if you like. Thank you very much, guys. All the best.
Thank you.
Thanks, everyone. Wonderful insights. Thanks, everybody.
Thank you again to our sponsors, Bricsys. If there's any questions, we will definitely forward for our panelists to answer after the session. And now I would like to move on to the presentation by Dhanjeet Sir, National BIM Manager at Rothelowman. Now over to you, Dhanjeet.
Yeah, hi. Just confirming, is everyone can hear me?
Yes, all good, Dhanjeet.
Perfect. Thank you so much for confirming, Olga. Yeah, so yes, good afternoon, everyone, and welcome to the presentation on DYNAMO for BIM managers and documentation. And I'm really pleased to show some of our case study, in the sense there's some of the scripts what we have been using and where we are heading in terms of DYNAMO. So quickly, I will just move to the next slide, which is so the presentation is all about some of the DYNAMO scripts used for everyday users. So my role at Rothelowman is National BIM Manager, and we are architectural, interior, and urban design practice, and we have specialized in commercial, mixed-use, residential, urban design, retail, tourism, and hospitality. So we are over 160 staffs in total. We have offices in Victoria, New South Wales, and Queensland, and we continuously cross studio pollinated a national design committee with local knowledge and relationship. So overall, we are one fully linked practice with substantial capacity. And some of our clients are some of our valued clients in the list here. So I'll quickly run through my introduction. So I have around 22 years of experience with AEC Industry, and my primary role is at Rothelowman is about BIM management, Revit content creation, setting up projects, BIM support, induction to new starters, and providing training for the internal staffs. I'm also involved in variety of projects in commercial, residential, mixed use or townhouse projects. And I'm also responsible for managing BIM team, and we are focused on developing BIM workflow and automation to drive efficiency in our workflow. I'm also one of the certified instructor from Autodesk on Revit, AutoCAD, and 3ds Max, and I've been speaking with some of the events. And as my previous experience, I've helped 10 plus architectural or home design company from moving from 2D to Revit workflow. And I was awarded as Customer Satisfaction Award from Autodesk in 2011. As a hobby, I love tennis and fishing. So let's get started with the software, DYNAMO. I believe some of you must have heard this software, and the DYNAMO Studio is a standalone program that runs on their own, and it has extended its capability for different software like Revit, Civil 3D, Alias Design, Format, and Advanced Still. So my presentation will be more focused on DYNAMO for Revit, and I will share some of our experience with some of the DYNAMO scripts, what we use as a regular basis. So DYNAMO for Revit is integrated with Revit. It's a visual programming tools that helps us to do automate repetitive tasks to be more productive. We can also use it as to test performance and explore multiple design options. And this is also a really soft entry for a digital skill growth. So this is one of the slides I just wanted to share, like how we are using DYNAMO script for different phases. And I believe it's really small. I mean, I apologize for being a very compact, but the texts are pretty hard to read, but I believe it's just giving overview. Like in different phases, we have number of scripts. The blue ones are really huge time savers, whereas the greens are something it saves a few minutes to few hours. So I'll be showcasing some of the scripts in the next slides. So our journey, I started exploring DYNAMO in 2017 or end of 2017 or early 2018. Some of our colleagues were equally interested, so we started exploring and see how DYNAMO can help in our workflow. So we started creating few simple DYNAMO scripts that started helping us immediately. So some of the examples are, so I'll quickly run through a quick video. This could be just a minute, 2 minutes video. So what it does is basically creating, helping us in the simple tasks like creating work sets. So definitely the creating work sets might take sometimes just 10 minutes, but to maintain the BIM standards like the work naming conventions to be accurate for every project, we really wanted to lock this as a DYNAMO script so that when user use it, they will just follow our naming conventions. And also we had this particular scripts that creates sheets from the Excel file. So these were in the early days, we started creating sheets based on the Excel file. The reason why we started using, because we had drawing list for every project, and we just really wanted to utilize as a quickly to create those sheets. And we also had few scripts that started helping in the maintaining drawing standards. For example, changing the upper cases of the changing text, let's say to the title case or to the uppercase, etc. And also attaching, let's say, the model disclaimer in a particular file which we want to share with the clients. So this was our first introduction to DYNAMO in particular year. And then we started looking at slightly more complex tasks. So we had few scripts that started helping and started saving few hours, not just few minutes. This is an example of scripts where we basically, the user need to create, let's say, multiple views, for example, the GA, and then again, they have to create fit-out plans, or let's say superstructure plans, or so on. So, and the general practice is, yes, we can create floor plans in few clicks. They will create for every level. So let's say if got 25 levels, we can create floor plan for 25 levels, but the renaming is the tedious task. So user has to go and rename. That means adding a prefix, for example, GA, dash, and level 1. And if it is SSP, they have to add SSP and so on. So we started using DYNAMO scripts, and what it does is basically it creates views with a particular prefix, and it will add view templates, and also it will sort out or organize in the browser, in the project browser, as we wanted. So this is a quick example. For example, we can select all the levels, and then if I click play, it creates in a fly. And for example, if I want to create a separate set of view, for example, superstructure plan, we just give the prefix, select levels, and then just hit and play. That's basically creates all of these view with a particular naming conventions. So this has started saving few of our hours. And the good thing about that is when we create these views, of course, we can nominate what view template we want to apply. So this was a quick, some of the quick time savers we started using from the DYNAMO. So the next, going to show one of the, for example, as in the same view creation, for example, if we have to create the RCPs, it's a very similar process. And then just one few clicks will create all the RCPs required with the particular template as well. This was a really interesting script I've created, was to basically to create a whole set of a particular view. So for what it does is basically place all the 4 elevations and create 4 elevations placed on the seats with a particular view templates. And this is one of the script was really interesting, was to create internal elevations from a particular room. And what it does is basically creates a seat for that, placing all the views with the scale or with the view templates applied onto that. So this is one of the feedback. I started collecting some of the feedbacks from the user, where in one of these projects that has 70 levels, and the user was required to create dependent views. That means like we wanted to have south and north elevation, south and north plan views with particular templates. So the user has indicated like it could have taken a full day to create that, whereas with the DYNAMO we have created within an hour time. And the next day, she basically came back to me and say, hey, that was great. The fit out plans I was able to create. Now, how about the reflective ceiling plans? So for me, it was like maybe 20 minutes to just to change the script and then create a new one, save as, say, we want to use the same script for ceiling plans. And then again, we saved almost a day for this particular user. Now, this is one of the another script I would like to showcase here, which is a really one of the complex script. And this is originally created by one of our colleague. His name is Reza. And this is basically the user need to require to input the apartment number and just hit play, and that will basically create a marketing sheets. And there is an additional script that basically adds some key plans on the seats as well. So in this particular example, we notice the user basically just need to key in the apartment number which is, and thus if they hit play, it creates a seat. It plays the view on the seat, and it also applies the view templates. It creates the schedule based on that apartment, and also create a schedule which is all the similar type of apartment on different levels. And there is a next script basically that's trace out the area lines to generate area plans based on that nominated apartment number. So we user basically just need to input few parameters and hit play, and we can simply start getting as an output as a key plans. So the next step is basically to just nominate another apartment number and say which floor it belongs to, and just hit play and then start creating the key plans for the next apartments. So this has basically saved quite a lot of time in our creating marketing stage. So I'm going to just move to the next slides. Now this is a really interesting one of the case study when I was started creating a Dynamo script for door renumbering. We realized definitely it requires a bit of understanding of how our workflow is, how we create things or how we manage things. So we were able to create basically this script, but the final, I would say the final result was not 100%, but it was like between 80 to 95%. So this is something like we discussed with the team, and we see a few things. So in simple terms, I would say the Dynamo is great. It can achieve a lot of things, but not 100% everything all the time, because every project would be unique, and every project may have a different data representation. So the best way is to basically just make the BIM standards that tailors to the Dynamo scripts, which is again we are looking into in depth in our workflow. So as this example, what we done is like we had established we had already established few workflows, and we just needed to do extra thing for this particular script. When the red one, as I mentioned here, is called all doors should have room calculation points. So this was not part of our project, so we had to spend maybe some extra time to do that, which was maybe a couple of hours, and then we were able to run the door renumbering. So this is one of the video I'm gonna showcase is door renumbering, where the user basically needs to just nominate what is the door prefix and just hit run, and that will basically rename that will renumber the doors on the apartment. So in our case, our drawing standards required the entry door as unit number .D1 and the rest in the clockwise direction, and that applies for every apartment. So we had one project recently. I ran this script, which saves few days of worth of work. It has around 900 apartments, so this was a really interesting output from Dynamo. So this is one of the Dynamo reached ROI on a project. So this is one of the project we are working on is 72 floors, has 885 apartments, and they started saving a lot of times on a particular task. So for example, for floor plan creations, we save 20+ hours. Area conversion to rooms. So in our workflow, we use areas first for town planning, and then when we move to DD, we start using converting the areas to rooms for other purpose. So there used to be manual process. It used to take 3 to 5 days. For Dynamo scripts takes few hours, in the sense the script takes maybe half an hour, but to match the data and all, it might be half a day work. So at least, again, we are saving a lot of time. And we also saved a number of weeks on creating marketing package. and we saved a number of times on a number of days as well on door renumberings. So in simple terms, the bigger the project, we are going to save more time on that. So as we started introducing these scripts to our users, as a practice, we wanted to make this simplified version for users. So we created a documents and placed on our intranet that has all the scripts available with the video and with the instruction. So user can simply refer to these particular documents and find out which script can help to them. But apart from these documents, definitely we ran training internally so that people will start taking advantage from the day one itself. So as a user, what we did was we started creating a very simple documents, and then we added a number of instructions on every scripts. So if I look at in the right hand side at the bottom, we have seen there is something called notes that has all the instruction required from the user. So it is a kind of like a guide for the user. So users just need to click on edit inputs and can refer to the notes, and they can input and they can start using these scripts. So some of the requirements and expectation management, and this was really important when we went for version 2, because people started expecting to fix everything from DYNAMO, but that was not the case. So we clearly mention and set expectation from the user that it may help, but not 100%. So, and some of the scripts that require some data preparation and customization per project. So if someone wants to use these scripts, they allow us some time to access the project and see where they are, what changes are required, and then we create or customize scripts for that particular projects, because every project may have some different data created. Because some projects we are digging out from, let's say 2014 or 15 or 16, and they might have created slightly different than what we practice now. So this setting expectations to the project leaders or to the associates was really important. So I'm getting some questions now. I believe we are we have a compact time, so I believe I've shared some information and you might have found some interesting. So I'm accepting some questions from the users. And I can see there are already some of the questions here. So I've got one very good question. How do we manage your packages? That's for us. I mean, there are definitely different and smarter way to do that. For us, we got 3 servers, like having offices in 3 different states. So in simple terms, IT has granted me admin rights for that particular space. So basically, I'm the single person managing that package, which is much more easier compared to leaving everyone to do it. So what I have done is having a same package replicated on 3 servers, and then we have a login scripts that basically sets the path for DYNAMO package path for the users.
Thank you, Dhanjeet, for answering all the questions. I think it is time for this presentation now. So thank you again for your presentation, Dhanjeet. And now I would like to introduce, thank you very much. Now I would like to introduce Peter Rautenberg, Infrastructure and Construction Manager at Deswick. Now over to you, Peter.
Oh, there we go. Hi. Just want to check that everybody can hear me and that you can see my screen. Can you just confirm that that's the case, Olga?
Yes, they're all good. Thank you, Peter.
Perfect. Thank you for your time. Sorry, I wasn't able to do the pre-check. I was in Brisbane time, so we got that hour confused. So I'm talking from Brisbane. Nice to meet you all. My name is Peter Rotenbach. I come from a quantity surveying background. I'm a chartered quantity surveyor, and I spend most of my time in the heavy industry, mining, infrastructure, oil and gas type projects, specifically in the project controls world, estimating, risk management, and planning. So today I'm going to talk about how we can use algorithms and mine planning technology to automate and optimize projects. And I'll start off by talking about why this is important, especially on the major projects front. Our track record in construction is pretty poor. I'm sure people in the call have seen these graphs before, but the graph on the left is a study that's been going for quite a long time that shows that since the 60s, construction's been lagging other industries like manufacturing. And earlier, you could hear the panel touch on these things where, we're talking about a Tesla that's got 8 cameras and collecting all this data. And on most construction sites, we're not even capturing the data on paper properly, in my experience. And it hasn't gotten much better. The graph on the right shows that in more recent times, the trend has continued. And not only is our productivity historically quite poor, but our ability to accurately forecast or predict the future is also quite poor. The graph on the left is a McKinsey graph from 2013, so a couple of years ago now, that showed how major projects either overrun cost or time. Now, the bright red line on the graph on the left is actually where a project would have been delivered on budget, and the one at the bottom is where a project would have been delivered on budget, and the one going from north to south is where a project would have been delivered on time. And as you can see, almost all of the projects in this data set were over budget and over time. It was more a question of how much. So they weren't able to, all these projects blew their budget and their costs. And on the right, there is a table from a famous researcher called Ben Fleetberg at Oxford University, who's found similar things and similar trends on these large projects. So why are we losing value? So I think on the one hand, we've understood that we're not very good at producing these large projects effectively, and then on the other hand, we're also very bad at predicting the future. Now, some of the key reasons that we're losing value, and this is from a very recent McKinsey report that was released, I think, a few days ago. I found it and I thought I would throw it into the presentation because it aligns a lot of what I believe. And one of the first reasons that it says that we lose the value is because we live in a very siloed world in the construction industry. We've got the design teams, the construction teams, the QA teams, the planners, the estimators, the quantity surveyors, all kind of working for their own companies and often having their own interests. And it's a very siloed process, and we lose a lot of value throughout the process. We're also very slow to adapt to our customers' needs in the construction industry. We follow a very phase gate waterfall process, which has its merits too, but we struggle with change, and we struggle with change during construction and during the design phase. We also find, especially in the large projects, our front-end engineering, feed and feasibility studies are quite poor, and when they hit the execution phase, what we planned isn't what happens. When we go a little bit deeper from concept phase into feasibility phase, we also find that lack of effective planning is a major issue. Planning these projects is very difficult because they get very large. They've got thousands of components. There's a lot of subject matter knowledge that needs to be applied to understand how to plan the project, and it just becomes very difficult. Again, we've got the siloed approach issue in the feasibility stage, and we often, in the planning phases, have a lack of constructability input. So, and we often hear that from contractors and people who deliver things on site, is that the designs in the early phase information that they get was not realistic. And we also do very little in terms of proactive risk management in the design and feasibility phases. We tend to react to risks rather than have plans for if and when risks occur, how to deal with them, and adequate provisions for those risks. Now, this graph, this slide is effectively the same slide as the previous one, just going into more detail and having information from other industry bodies, like the Independent Project Analysis Body. It's probably one of the most famous data organizations in especially the mining and oil and gas industry. They've got over 20,000 projects in their database, and they found the same issues. Processes are siloed, organizations don't learn from their mistakes, we lose information between handover, we've got poor planning, and we've got poor adoption of technology. And the point that I'm trying to get across is that these reasons that projects fail are often not found in our risk register. I have not seen these types of issues on any risk registers that I've looked at lately. The risk registers have got more discrete event type risks, like, oh, it's going to rain a lot, or maybe people are going to strike. But that's not really what causes our delays. What causes our delays are these issues. Now, the good news is that the industry is doing something about this. And today we're talking in the BIM panel, which is quite exciting. And one of the big responses that the industry has had to this is the ISO 19650 standard. And also we're seeing BIM standards and digital engineering standards across the world. And the idea behind this is to make us less siloed and work together. Now, what the ISO standard tells us is it tells us who's responsible for what information. It defines what the project information requirements are. It defines what level of detail we need at the different phases. It also tells us how to plan our information requirements and then how to share that information between ourselves as a project team once we've got it going. And the little image that you can see at the bottom right, I believe depicts it quite well. So we're moving from a world where we have all these different parties talking to each other in different ways to a world, to the picture on the bottom right, where there's a common way of sharing information and data and using that information and data. And that makes a lot of sense. And it's also not just a concept. BIM is real, digital engineering is real. It's being applied in Australia and many jurisdictions around the world and by many companies. So I think it's a trend that's going to keep going, and it's something that we need to understand very well for the future. But then we also have to ask ourselves the so what question. So we've got the structured data now, but so what? That doesn't necessarily mean we're going to deliver a more successful project. It's how we use the structured data that will actually have an impact on our project cost and budget at the end of the day. I just want to click there. Yeah, just wanted to check if you've got any questions. We're all good. So now I'm going to jump a bit into my world, which is the planning and scheduling world. And there's a big difference between planning and scheduling. Planning is where I like to refer to as defining the constraints. That is where we answer questions like, what must be done for this project to achieve its goal? How will it be done? Who will it be done? What strategy are we going to use to do it best? And when is it actually required by? When are the parts within it required by? These are the big questions that we ask to achieve the project goals. So that's defining the constraints. Then what we refer to as scheduling is actually modeling those constraints. So we take all those constraints that we have, we take the project scope, our resources, and we develop a schedule. And a schedule is effectively a time sequence of activities, which we often refer to as a Gantt chart, and programs that we're used to seeing schedules in our Microsoft Project, Primavera, even Excel. And that's a depiction of how we're going to achieve that plan. So we need to distinguish between planning and scheduling. Now, the proposed approach is, what this presentation is about, is that we take BIM data, which is 3D models, information, quantities, GIS information, so that's effectively our scope. And then we also take our organizational knowledge, which is a planning input, our clients' goals, our historical norms, so historically how long it's taken to do certain tasks, our sequencing rules. We know that we need to install the columns before we install the slab, and our resource loading. And we actually take that those planning inputs, and we take the 3D models and the BIM data, and we combine them, and we automate the scheduling part. So we try and automate the modeling of the constraints by combining our planning inputs and our BIM data. And then by automating that, we can very quickly get feedback on what our project is going to look like, and what our schedule is going to look like. And then we can feed our outcomes of our project back into our design and back into our planning, so that we can develop better projects early on, and we find our mistakes before they happen on site. So to go a bit further into this approach, we believe that you should build it twice. You should build it in the virtual world first, make your mistakes in the virtual world, learn from it, and then do it right when you do it in the physical world. We also believe in an integrated approach to planning. We believe that you should use all the information that you can now, rich GIS, 3D, metadata, historical databases, plus our subject matter information, like rules, constraints, and project logic, and we should apply all that information to come up with a realistic schedule and a realistic plan. It's also great to automate the scheduling process, because at the moment that is extremely time consuming. So we automate the scheduling process, which is the doing part, by using algorithms, derive tasks and process maps, and that allows us to do more of the thinking work. We can also apply real world constraints. Often in our critical path or Gantt charts, we don't apply real world constraints. And what I mean by real world constraints is, for a certain amount of time, we may have Omar mentioned it earlier, we may have a lack of concrete available. So we should actually be able to build those constraints into our schedule. Another consideration is spatial constraints. We know that no work can occur under a suspended load on site. So we don't want to plan any tasks within a suspended load. At the same time, on these large projects, we often have spatial constraints where work cannot occur within a certain residential area at certain times of day. We need to be able to model those spatial constraints in our schedules. And then we also want to be able to model our resourcing constraints and other constraints. And then the last principle, which is quite important, is being able to run as many scenarios as possible, so we can provide that feedback back into our design and back into our planning process, thereby optimizing value. I haven't been timing myself. Just give me a shout if I'm going too slow. The other point is that this approach is not new. This approach has been used in the resources industry by hundreds of companies across the world. And this integrated approach of using your smart models plus your codified organizational information planning is being used every day by hundreds of operations around the world. It is a rather new concept to the construction and infrastructure industry, though. So to illustrate the points that we made, the first one is build it twice. So in this example, we can visualize the construction of the tunnel, and we can visualize the cash flows, and really have a good constructability review of our approach before we get to site. We also spoke about using an integrated approach to plan the project. This is very important. So we get the BIM data, we use the BIM data, and that can be IFC, whatever information we receive. It can also be the existing terrain models. And then we also use GIS data, which can be structured jurisdictional data like land tenements, which have big impacts on our schedules. And it can also be unstructured or project-specific GIS information like standoff zones, safety rules, all that type of stuff. Another very important aspect for us, especially coming from a mining background, is the geological model. Obviously, if we encounter difficult geological conditions underground, they have massive impacts on our projects, especially on our infrastructure projects. And lastly, and probably most importantly, is our project knowledge. So this is the the safety rules, the sequencing rules, the historical performance rules, and all of our project knowledge needs to be incorporated in our model too. We then automate the schedule, and as I mentioned earlier, this is a very important part because it gives us the time to go back and spend more time on the thinking. We automate the schedule by using the geometrical information, the metadata, our scheduling rules, and then pushing them into a Gantt chart format or a schedule. And by using this approach, we can schedule detailed plans, sometimes 10,000 up to 1 million tasks, which is what these big projects need in quite a quick time frame. And we can schedule multiple scenarios, whereas if we try to do that manually, it would just be impossible. This is a little video to show you an example of what it looks like. So in this example, it's a linear project, and it's going through multiple tenancies, as you can see at the bottom over there. We've created our rules beforehand. We use the BIM data, and we start deriving our tasks from our BIM data and our specific rule sets. So slowly on the right-hand side of the screen, you'll be able to see that the tasks are starting to be created based on our rules. And then after the tasks are created, the engine goes through and starts creating our sequencing based on those rules too. So in that example, we had about 1,300 tasks that were created, and basic sequencing for those tasks were also created based on our rule sets and our historical information and project knowledge. What we then do is we take this Gantt chart that we've created now, and we apply resourcing to it. And we've got rules for our resourcing too. So in this example, we've said that if it's this type of activity, go grab a resource from this pool and assign it to the project. And then we level those resources based on the amount of time that those resources have available on site. And because, again, this was done fairly automatically, we can now focus on our analysis. And in this example, we can see that the approvals process is what's really driving this project. So there's no point in spending more time trying to improve the productivity of up to full crew when it's the approvals process that's definitely driving this project. So we can either decide to change our approach if we want to make it shorter, or we can accept the schedule. But the good thing about it is we can spend more time on analyzing and running scenarios rather than doing the grunt work of scheduling. So yeah, as I explained, we use the metadata and the quantity information to derive our tasks. That's very important. And it's also very important that we receive the designs in a good state. And they need to have good metadata standards, and everything needs to be defined fairly well for this process to work, or for this process to be efficient. Another important point is applying real-world constraints. So in this example, we've got concrete being delivered to site, but we've actually unconstrained the concrete for that specific area. But let's just say we knew that for a certain reason, maybe because it's busy, or maybe because of some other, maybe just because of it's a real-world constraint, we won't be able to keep more than 150 cubes per day for that specific area. What we can do is we can apply a material constraint to that area, and immediately our schedule is updated and our quantities are updated. We can understand the impact from both a cost and a time perspective. As I explained, we need to apply real-world constraints. For us, what's underground is often quite difficult to deal with. So we need to understand what type of rock and material we're going through, where we have groundwater, and then we need to decide how we will deal with those difficult areas and build it into our schedule logic. And this is an example of a tunnel going through some hard rock on the right. And then the last real world constraint that I'd like to show is that very often on projects, especially going through metro areas, there are noise limitations or certain standoff zones. So in this case, because we've got a spatially linked schedule, we can say within a kilometer of that area, you are not allowed to work between 5 p.m. to maybe 7 a.m. And we can actually apply those calendar constraints to our schedule from the spatial logic because we have this information, in our BIM models. Bringing it all together, so by following this approach, it helps by integrating the BIM, the structured and the unstructured data sources. Planners on complex projects are able to develop, control, and most importantly, constrain and automate schedules to reflect real-world outcomes and run scenarios to optimize those schedules. This helps us maximize value through iterative scenarios, and we can efficiently model the dynamic, spatial, and temporary constraints on a schedule. And this theory of constraints approach helps us manage risk and identify opportunities, and actually select better ways to do projects early on when we still have those options. That's the end of the presentation. Thank you very much. I will stop sharing my screen.
Thank you for your presentation, Peter. And now for our last presentation for today, I would like to introduce Ken Lee, Group BIM Manager at Robert Berg Group. Now over to you, Ken.
Hey everyone. Thanks for tuning in this afternoon. The presentation is set up. Excellent. Thanks, Olga. I'm the Group BIM Manager for Robert Berg Group. So I provide strategic support and direction for the company as well as develop our BIM capabilities from management application to automation. Next slide, please. Robert Berg Group, as an engineering firm, was founded in 1984. We've since grown to over 600 staff across ANZ, Asia, Middle East, and the UK. And we've also expanded to North America in the beginning of 2019. So since 2017, RBG joined the Surbana Jurong Group, boasting a group staff of 13,000, over 44 countries, with 1.3 billion turnover. Next slide, please. So as specialist engineers, we have 4 core services, which are structural, civil, geotechnical, and construction engineering. Now we have also four interrelated pillars relating to all the structural, civil, geotech. So BIM is one of those 4 pillars comprising of BIM management, automation, and digital design. In 2019, Robert Berg Group launched our engineering and technology initiative. So the intent is to utilize, maximize with our engineering expertise. The virtual design construction therefore acts as a vessel for our digital engineering solutions to be illustrated in the virtual space. Next slide, please. So today I want to talk about BIM for constructability and focus on reinforcement bars and congestion coordination. So this is quite a fascinating topic because as BIM users, we conduct a lot of coordination modeling and what I call jigsaw puzzling work, whether manually or through extensive automation. But when it comes to reinforcements, the utilization of BIM becomes evident, especially when there is a need for an extraordinary amount of rebars jammed into a confined space. Next slide, please. So there are two projects which I like to show, and they revolve around the cantilevering of structural floor beams, which in return supporting multiple levels on top of the cantilevers. So anchoring the cantilevered steel beams are pre-stressed high-strength tendon bars located within the core walls. So encasing these pre-stressed bars are multiple types of reinforcement. So if you can imagine reinforcement just encasing the entire structural wall. So both projects require RBG to provide proof of concepts mock-ups, which we then erect off-site before our erection on-site. The next slide, please. So the very tight deadline meant that our engineers need to develop and design all the reinforcements within the cantilevered structure with our BIM technicians modeling in parallel. Now, this is not ideal because designing and modeling in parallel will almost certainly result in error-prone output. But we had to do it because of the 5 to 6 weeks of tight deadline. So the deliverables need to be fit for purpose. It needs to allow for accurate quantification. We have to ensure buildability. This range from being able to fit all the bars in place, bend various bars manually, and allow enough room for manual maneuvering. We also need to identify clash points and identify alternatives. Now, the congestion issue within these walls, as you will later witness, enabled us to use BIM to resolve all these issues within the designated time frame. Next slide, please. So the first short clip, you can play that clip, Olga. I want to show is 80 Collins Street. So I've got two similar projects. This is a 38-level office tower providing 43,000 square meters of premium office space and 255-room boutique hotel. As the clip will show, there is a core to the left of the building, jumping at around 4 stories within a core, and there will be a set of diagonal steel beams extending out to support another 30 stories of floor space. Now, the diagonal beam uses the core walls to cantilever and hold everything in place as you're witnessing now. The walls supporting the diagonal beams, the walls itself, inside the walls itself, are the pre-stressed tendons and reinforcements. And they are extremely, extremely congested because it's used to hold up the rest of the floor. So in this particular video, you'll see a shortcut of the floors jumping and the levels being built pretty quickly. And our basic remit is to enable us to design and model and conduct extensive clash coordination to make sure that all the reinforcements in that core wall can be built firstly within the mock-up and then on site. So the next slide will be 405 Burke Street. Now, these two projects are very similar because both use the same core walls within the core to build up to provide the cantilever required. If you can play that over, please. Now, this is an office tower consisting of 39 levels with over 30 floors as well, 66,000 square meters. This site is particularly narrow. The cantilever structure protrudes into the airspace of the adjacent building using enormous steel trusses as well as steel beams. Both 405 and 80 Collins Street demonstrates how we are using BIM to firstly model, conduct extensive what we call a micro clash analysis and micro level coordination, because every steel reinforcement needs to be accounted for. We need to ensure that when we are doing the mock-up on site, we can actually slide the reinforcements in. So we have a warehouse to do sort of a small area of it, and then we start sliding the reinforcement in. So what you're seeing now is the steel truss holding a cantilevered structure on temporary works, and we're building that on top. What you will see on the side there, where the cores are blue steel beams coming out, and those steel beams is where the cores are supporting. So whenever you see steel beams coming out, the cores are supporting the steel beams with the core using pre-stressed tendon bars. So as it builds up, the trusses are holding the bottom part of it, and the top part will be based on additional walls and steel beams to support it. You play that slide. Thanks, Sagar. So what does it look like? So these two images show how congested the areas are. So we have pre-stressed bars crossing over for the entire wall. And we have the overall picture, and the pre-stressed bars goes from one end to the other. But the steel beam that protrudes from either ends are different in sizes, uses, and connections. So you have different steel plates connecting to each other on different side of the bar, but the pre-stressed tendon goes all the way. Along the wall, you have pre-stressed tendon bars, and you have different reinforcements encasing it. The difficulties stem from the horizontal bars extending from one end to the other. The congestion becomes even more complex because the configuration steel beams are connected via the end plates in which you can see it blown up. In later slides, I'll show you a rotation of that corner. Next slide, please. So we created a lot of connection drawings, look at different levels and different connections in 3D, and we had to sort of print this out in AO and basically just marking it up and having a look at the 3D model and manually marking it up, because sometimes you can't really mark it up. You have to look at it at a different angle and mark it up on plan. So this is just an example of the level of detail that we went through to produce this massive sort of configuration. And this applies to multiple levels, just not just the one level. Next slide, please. You can play that slide. So this next slide, this is the last slide which I'm going to show. It shows the complexity surrounding this congestion. As you can see, you've got a sort of a L-shaped wall. You've got plates hanging off two ends. You've got beams coming out of it. You've got pre-stressed bars going through both directions, and they interlace. You've got vertical bars coming in, slotting in. You've got horizontal bars going in both directions, and you've got ties holding everything in place. So this blow up will showcase and focus on this specific corner, and you can see how congested everything is. So what we did was, this is all done in Revit. So we didn't use Tekla or Advanced Steel for the plates. And Revit itself is capable of producing something as complex as this. However, there are a few lessons to be learned from this. Next slide, please. So one of the few lessons learned is to avoid, for clash avoidance and clash analysis, is what are the constraints? Which bars are immovable? And which ones can be adjusted to suit. So we started off by identifying the immovable bars, immovable pre-stressed tendons, the plates, the connecting beams, and then we'd start to develop from one end to the other. And the tricky part is once you develop on the south end, the north end will become unusable, because as your horizontal bars goes through and the vertical bars come in, you'll find that even the lap, it creates a lot of trouble and problems with it, because as it reaches the far end, it doesn't work anymore. So we have to spend a lot of time identifying the clashes and identifying ways to fix it. So it's really a collaboration between the engineers and the BIM technicians. One of the things that we do need to be aware of is the minimum concrete cover. So we do identify that, as well as the immovable stuff. We have clear ways and sort of zones to sort of identify which areas we can move and which areas we can't, and placing placeholder boxes, etc., does necessarily help. So this is what we've done in I think about 4 projects now in terms of clash coordination. And finally, we have to know our bars. We have to know what are the bend radiuses, what are the dimensions. All these knowledge add up to being able to sort of service this complex micro clash analysis and BIM coordination work. That's it for my quick presentation.
Thank you very much, Ken, for your presentation. Since we're running out of time,
Yeah,
I would
no.
definitely send over any questions for you to answer after the session.
Thank
Thank
you.
you very much.
Designed to speed up high-rise development projects, the 275mm profile is part of Dinsel Construction Systems' internationally patented, Australian engineered and manufactured polymer formwork range. Proven for its speed of building benefits that can reduce total construction time by half. And third-party strength tested to rigorous Australian building standards, proving its ability to be used in high-rise developments without potentially needing steel reinforcing. The structural forms can be easily snapped together with the patented joint system. They can be used in walls and columns of any height without the use of cranes and other lifting devices. Dinsel 275mm is a BCA compliant and waterproof certified structural walling solution that can be used from deep basement up to 60 stories. The 275mm profile features an innovative internal ring form which increases the strength of the profile significantly. This unique design also allows the use of two 10mm slump concrete mix in a high-flow, single continuous pour up to 4.5 metres high. Concrete core samples reveal the high quality of the pour. No air voids or honeycombing. Our in-house testing simulated the triangular backfilling scenario using 3-metre lengths of unfilled Dinsel 275 and 3 tonnes of uncompacted fill. When the full weight of the uncompacted fill is pushed against the structure, even with minimal bracing, you can see that there is essentially no deflection, warping or decrease in the structural integrity of the unfilled walling panel. Dinsel 275 filled with minimum 32 MPa concrete, cured for at least 24 hours, can be safely backfilled against and compacted with a maximum 5-tonne tracked machine. To confirm this claim, Dinsel commissioned the University of Technology, Sydney to test the flexural strength of the concrete-filled 275mm profile. The capacity of the 275mm Dinsel flexural unreinforced specimens at 24 hours far exceeded the load which would be imposed by 3 metres of soil. Proof positive that early backfilling of soil, 24 hours after concrete pour, can be scheduled for projects using this profile. The capacity of the 275mm Dinsel flexural reinforced specimens has significantly more capacity in comparison to a conventional concrete wall with the same thickness, concrete strength and reinforcement. Bar chip fibre reinforced concrete was also utilised within 275 Dinsel with positive results.
That's the end of the session. Thank you very much to all of our speakers, our sponsors, and a big thank you to everyone who has joined us in the audience today. You will each receive an email with a link to an on-demand copy of today's session. This is normally sent within 48 hours. Please tune in for other sessions that are available both live and demand this week. From the 7th to the 11th of December, we have sessions running in both the morning and in the afternoon. You can log into the event platform and plan your agenda and add them to My Event Planner to create a customized plan for your week. You can also click on the sponsors, message them, and set up meetings with attendees, speakers, and sponsors. We do hope you enjoyed this webinar and very much looking forward to seeing you in the future. Thank you.